Okay, in this video I'm going to just do the first 4, and then I'll do the next 4 in the next video. So right away I'm jumping into overlapping triangles. Okay, I'm not saying you have to do what I'm going to do, but it's a good idea. I want to prove that triangle LMP is congruent to triangle PQL, so I'm going to separate and redraw those. So LMP, and I'm going to mark angle L as a right angle, and then LPQ, and angle P is a right angle. Okay, so here we go with the proof. I'm going to say angle, and I can't say angle L because there's multiple angles there. I'm going to say angle MLP and angle QPL are right angles. That's given. Okay? What that means, angle MLP and angle QPL are congruent because all right angles are congruent. Okay? So there's one statement. We already kind of have it marked. I also gave you that MP is congruent to QL. That's given. I'm going to mark it now. MP is congruent to QL. Okay? Last thing, look for that shared side. We talked about that with overlapping triangles. They all have a shared side or angle. Look for that thing that's shared. In this case, it is LP. So LP is congruent to PL. And that's the reflexive property. And now I have the two triangles are congruent. So triangle LMP congruent to triangle PQL because of HL theorem. Right angles, a leg, and the hypotenuse. So HL theorem. Okay, I would say that one, after you redraw it, the difficulty level is probably about a 3. Before you redraw it, it's probably about a 4, 5. So separating and redrawing it makes it a little easier for most people. Okay, this one is probably about a level 4 or 5. Let's create some space here. So I want to prove that angle E and angle A are congruent. The reason this one's tricky is because there's multiple triangles here. But what I see is that angle E and angle A are part of triangle DBA and DEF, but they're also part of DEG and DAG, or DAC. Not sure which one I'm going to use yet, but let's get started. We'll just jump in with the given. GC bisects FB, not angle, FB. That was given. What does that mean? That meaning, what we can figure out from that is going to probably lead us in the direction we want to go. GC bisects FB. So GC cuts FB in half, which means FD is congruent to BD. That's the definition of bisect. I also marked DE is congruent to DA. Let's mark that down real quick. DE is congruent to DA. That was given. I need one more piece. I have vertical angles here. So I have that angle and that angle congruent. I have angle FDE is congruent to angle BDA. Vertical angles theorem. That should be enough to say that these two little triangles here are congruent. So triangle FDE is congruent to triangle BDA. Why? Hopefully you understand why. Side, angle, side. And now I can say angle E is congruent to angle A because of CPCTC. Okay. Number 25. I'm going to prove that AD is congruent to CB. Probably going to have to prove those two triangles congruent. First thing I'm going to say is AB is parallel to CD. That's given. What does that mean? That should lead to something. That means angle BAC is congruent to angle DCA. That's alternate interior angles theorem. So I'm going to mark those. Those two angles are congruent. I also gave you that angle BCA is congruent to angle DAC. That was given. Those are actually different statements. BCA is this angle here. DAC is this angle here. There's two. Last one is going to be CA is congruent to AC because of the reflexive property. So I'm going to mark that. And then the two triangles are congruent. Triangle BAC is congruent to DCA because of angle side angle. And again, I'm assuming you know how to do that. If you don't, separate and redraw those. Okay? But the side that's marked is between the two angles that are marked, so it's angle side angle. Now I can say that AD is congruent to CB because of CPCTC. Okay. BK bisects angle VKT. B is the midpoint of VT is what we're trying to prove. It's a little different on this one. First thing I'm going to do is I'm going to mark the two. I'm going to say the two things that are congruent. So VK is congruent to TK. I also know that BK bisects angle BKT. It's given. What does that mean? If BK bisects angle BKT, that means angle VKB. Try that again. Angle VKB is congruent to angle TKB. That's the definition of angle bisector. Okay. I'm going to go ahead and mark those. And then BK is congruent to BK because of the reflexive property. And now I can say that the two triangles are congruent. Triangle BKB is congruent to BKT because of side angle side. Now, this is where it gets a little tricky. A lot of people want to say, oh, then B is the midpoint because of CPCTC. That's not true. Okay? If B is the midpoint of VT, which is what we want, we would have to show that BV is congruent to BT. The only way to say that is because of CPCTC, and that's what I'm going to say next. BV is congruent to BT. CPCTC only says two parts of a triangle are congruent. It does not say it's the midpoint. It does not say it bisects. It doesn't say anything other than two things are congruent. So CPCTC says that those two things are congruent, which means B is the midpoint of VT by the definition of midpoint. And there's the proof for that one.